Okay, we're going to look at a little review sheet that I created to help us prepare for the test. This is the Unit 4, Part 1, Adding and Subtracting Fractions Review. I am going to be looking at the we do side, which has already been done in class. And tonight for homework, you should be doing the you do side. So we're going to start out with making sure that we have everything we need to be successful. The first thing, obviously, is our homework sheet. We also need to make sure that we have a pencil. Do not use a pen in my classroom. And you are also going to need a piece of notebook paper. This is so that you can show your work. There is just not enough space on here for you to show your work. So let's go ahead and start and looking at the very first one, which is just asking us, what is the value of this expression? Now, truly, this is a pretty low order question. The only thing that I will note is that here it says use the slash sign as your fraction bar without any spaces. The reason I'm asking you to use the slash sign is because when we do computer-based testing, that is how we write our fractions. So I'm actually going to take this and rewrite it on my beautiful piece of notebook paper here. 4/5 minus 2/3 is equal to. And I'll zoom in so that you can see that a little bit better. So when I'm looking here at that, I should notice, well, I have unlike denominators and I need to create a common denominator. Now, of course, I've said plenty of times before, I can list my multiples for 3 and 5 and find that common multiple. So my multiples for 3, I have 3, 6, 9, 12, 15, 18, 21, and I'll stop there. That hopefully is enough, and if it's not, I'll just come back and extend my pattern. My multiples for 5 are 5, 10, 15, 20, and now let me just go ahead and check and see, do I have a common? Again, I can extend my pattern if I don't. I have a 5 here, no 5. A 10 here, no 10. 15 here, oh, I do have a 15. So that is going to be my least common multiple, which I'm now going to use to create a common denominator. So I'm going to take 4/5 and turn it into 15ths. And I'm also going to take 2/3 and turn it into 15ths. So I have that common denominator. So I'm going to look and I'm going to say, well, what did I do to go from 5 to 15? Multiplied by 3. And I know anytime I create an equivalent fraction, what I do to the bottom, I must also do to the top. So I'm going to multiply my numerator by 3 as well, which will create a new numerator of 12. So 4/5 is equivalent to 12/15. Now I'm going to do the same thing here. I'm going from 2/3 and I need to take it into 15ths. Well, what did I do to go from 3 to 15? I multiplied by 5. Now I need to do that same thing with my numerator. 2 times 5, my new numerator is 10. So 2/3 is equivalent to 10/15. Now that I've created my two equivalent fractions with like denominators, I can now just go ahead and subtract. I know that when I'm adding or subtracting, my denominator is going to stay the same, so I'm just going to go ahead and bring that 15 straight across. And now I'm going to perform my operation. 12 minus 10 is equal to 2. Now I always want to look and see, can I create a lesser equivalent expression, a lesser equivalent fraction? In this case, 2/5 does not have any common factors. I can't divide 15 by 2, so that is it in its simplest form. Now let's go ahead, and I want you to try 1/2 minus 3/8 on your own. So if you want to go ahead and pause, you can do that at this time. While you guys are doing that, I'm just going to take and put 2 with my slash sign 15ths into my equation editor. Okay, now let's go ahead and look at the next one. It's a multi-select, which means there's going to be more than one answer. That means that I need to work through all of my possible choices. So it says 7/8 plus 7/5, and I need to find all the possible values of the expression. So I'm just going to actually, it looks like I have a decent amount of space here. I'm just going to actually try to solve it here. 7/8 plus 7/5 is equal to. Now you're going to have students who are going to try to say, oh, I have like numerators, I'm going to add the denominator. No, we need a common denominator. So what is my common denominator for 8 and 5? Most students will quickly be able to identify 40, but if you do not, go ahead and list your multiples for 8, list your multiples for 5, and find that least common multiple. To go from 8 to 40, what did I do? I multiplied by 5. 5 times 8 is 40. And I know I need to do this with my numerator as well to create that equivalent fraction. 5 times 7 is 35. Drop down my plus sign. And again, I want to go from fifths to 40ths. So what did I do to go from fifths to 40ths? I multiplied by 8. And again, I need to do that with my numerator as well to create the equivalency. 7 times 8 is 56. So now I'm just going to go ahead and add, and again, my denominator can just go right across because it's not going to change. So 40 is going to go across, and now I'm going to add my numerator. 5 plus 6 is 11, so I'm going to put my 1 and carry my 1. 1 plus 3 is 4. 4 plus 5 is 9. So now I have 91 40ths. But I know that that can be represented in more than one way. So first of all, I'm going to box that because I know that that answer is fine. Improper fraction is great. I also know that I can regroup it into a mixed number. So I want to say, well, this is the same thing as saying division. 91 divided by 40. Or how many times can 40 go into 90? And I can even think my basic facts. My multiples of 4. Well, 4, 8, 12. Oh no, 12 is too high, so it has to only be 2. 2 times 40 is 80. So I'm just subtracting 80 from 91. 91 minus 80 leaves me with 11 40ths. So that is also an equivalent fraction. 91 over 40 and 2 and 11 40ths are the same. And there are many ways that I can rewrite this equivalency by multiplying my numerator and my denominator both by the same number. But let's go ahead now and we're going to check through all of our possible answers. Will 14 40ths work? Well, no, because that one's less than 1, and I know my answers are greater than 1, so I'm not going to do anything with that. 91 40ths? Oh yeah, that was the first improper fraction I came up with, so that one does work. 2 and 11 40ths? Yes, that's what I got when I took my improper and made it into a mixed number. D, 1 and 11 40ths. Oh no, I know that's not going to work because my whole number here is 2. And 1 is too low, so that's not going to work. And the next one says 2 and 22 80ths. Can I go from 11 to 22? 11 40ths. Is that equivalent to 22 80ths? Now the answer to that is yes, because I'm multiplying my numerator and my denominator both by 2. 11 times 2 is 22. 40 times 2 is 80. So 22 80ths is actually the same value as 11 40ths. So saying 2 and 22 80ths is the same thing as saying 2 and 11 40ths. So I'm going to go ahead and select E as well. Now I'll give you a moment. Go ahead and pause the video. I want you to try the next one on your own. Okay, welcome back. Let's look at the last one on this sheet, and this one is one of my favorite ones. We're looking for a missing numerator. This one might take a few extra steps, so just in case, I'm going to go ahead and pull out that beautiful sheet of paper that I used before. And I'm going to go down to a new line so I keep it nice and organized and write number 3. And now I'm going to go ahead and rewrite it. So I have 3 with something over 6, take away 1 and 3/4 is equal to 1 and 5/12. So the first thing I always tell them is let's just go ahead and rewrite it with that whole missing fraction part out. So I'm going to rewrite it now as 3 with a box in its place minus 1 and 3/4 is equivalent to 1 and 5/12. So now we need to say, well, what do we need to do now? Well, now I notice that I have unlike denominators, 4ths and 12ths. Well, what could be a common denominator? If I didn't know, I could list my multiples for 4 and my multiples for 12, but in this case, I recognize very quickly that I can go from 4ths to 12ths. So I'm going to go ahead and rewrite this with all my fractions, including that missing fraction part, equal to 12ths. And this one I'm going to just drop down. It's already in 12ths, so I don't need to do anything to it. But I need to look at this one here. I changed from 4ths to 12ths. What did I do to go from fourths to twelfths? I multiplied by 3. 4 times 3 is 12. What I do to the bottom, I must also do to the top. 3 times 3. So this numerator needs to equal 9. Now a great strategy that I could use is I could rewrite this as addition, and that would help me to find that missing number. So I think in this case I might go ahead and do that, but if I did not want to do that, the other thing I could do is I could say, well, I know this is 9, and something minus 9 to give me 5. Not really sure yet, but I do know if I look at these whole numbers, 3 minus 1 does not equal 1, so I know that that can't be it, which means I must have borrowed at some point from my 3 and made it a 2, which would have meant that I also had 12 twelfths that were regrouped from my 3. I took one whole and had it. So I have 12 minus 9, but also that 5 has to be accounted for, so 9 and 5 equals 14. If I add those together, they equal 14. So that means that if I need 14 and I have 12 that I borrowed from my whole, I would need 2 more in order to get that 14. So 2 and 12 is 14. 14 minus 9 is equal to 5. And now I check my whole numbers. 2 minus 1 equals 1. So the missing fraction that I got there is actually 2 twelfths. And I'm just going to rewrite it so you can see it nice and pretty. But I'm going to go back to my original fraction, and I see that my original denominator was not 12, it was 6. What did I do to go from 12 to 6? Very good. I divided, because I'm going to a lower number, I divided by 2. What I do to the bottom, I must also do to the top. So I'm going to take my numerator, and I'm going to divide it by 2 as well. 2 divided by 2 is 1. So my missing fraction part is 1. Now I'm going to actually show you this where you inverse it as well back into addition. So I'm just going to rewrite the exact same equation. 3 and something 6 minus 1 and 3/4 is equal to 1 and 5/12. And I know that I'm going to rewrite this with that part out, but I'm going to rewrite it as addition instead of subtraction. So I'm going to rewrite it as 1 and 3/4 plus 1 and 5/12 is equal to 3 and something 6. And I obviously right now I have completely unlike denominators. Oh, I was going to take that whole thing out actually. So let me just take that out. So I now have 1 and 3/4 plus 1 and 5/12 is equal to 3 and something. So what I'm going to do is I'm going to need that common denominator. And we already decided before, 4ths and 12ths, the common denominator is going to be, yep, it's going to be 12ths. So I'm going to rewrite it 1 and something over 12. Plus 1, this is already in 12, so I can just bring it straight down. 1 and 5/12 is equal to 3 and something. Now again, when I'm adding, when I have those denominators, it's going to go straight across. So this denominator now is going to be 12, and we'll turn it back into 6 when we get our final answer. So here I went from 4ths to 12ths. What did I do to go from 4ths to 12ths? That's right, I multiplied by 3. And what I do to the bottom, I must also do to the top, so 3 times 3 is 9. 3/4 is equal to 9/12. And now I can pretty much just add them up. Well, I know that 9 plus 5 is going to give me 14. Oh, but I know that they didn't have 14. And even if I look here, 1 and 1 is not 3, it's 2. So that means I must have somewhere regrouped. So I had 14, and I took away, I had 14, and I took away 12, and that's what gave me that extra whole. So that fraction should be 2/12, And now I'm going to take this answer that fills it in, 3n 2/12, go back to my original. My denominator was 6, and I got to 12. Well, what did I do? I divided by 2. So I'm going to divide by 2 again, which is again going to give me 1. So all I'm doing is putting a box in its place, using the numbers that I have given with a common denominator, and then solving for that missing fraction, taking it back to my original expression to create an equivalent fraction. I can do that by adding. I reverse this into addition, it was subtraction, and then I reversed it into addition down here, or I can keep it as subtraction, but either way, I'm replacing that with a box and finding those common denominators to help me solve.